Hello friends, welcome to Engineering Funda family. In this video, I am going to explain you range of signed data as well as how to represent signed data in computer. So in my previous video, I have told you in computer for signed data representation, we use 2's complement method, right? So here, I'll explain you how we can identify range of signed data as if number of bits are given to you. For example, if you have n bits, then what will be the range of signed data from negative to positive? So negative data, that will be as per minus 2 to the power n minus 1, and up to positive data, it will go up to positive 2 to the power n minus 1 minus 1. Let me explain you how we can identify the range. So for n bit data, range of that n bit, that will be as per for positive, you will be having 2 to the power n minus 1 minus 1, to negative data, that will be as per 2 to the power n minus 1. See, that is how range is there, right? Let me explain you this by few examples, so that will gives you more clarity. For 3 bits, what will be range? For positive number, it will be 2 to the power n minus 1 means 2 to the power 2, minus 1 means positive 3, to minus of 2 to the power n minus 1, so minus of 2 to the power 3 minus 1 means 2 to the power 2, so that will be minus 4. So for 3 bits, range will be as per plus 3 to minus 4, right? Let us have few more cases, like for 4 bits, range will be as per, for positive data, it will be 2 to the power 4 minus 1 means 2 to the power 3, that is 8 minus 1, so plus 7, that will be the positive data, up to negative data will be 2 to the power 3, right? So minus 2 to the power 3 means 8. So that is how we can identify that. Let me give you bit larger number over here. Let us have 9 bits over here. So for 9 bits, as if you want to identify range, then positive number, that will go up to what? 2 to the power 8. 2 to the power 8 is how much? 256. Minus 1, so that will be 255. To negative data, that is 2 to the power 8 means minus 256, right? So here, my dear students, you should even remember few numbers which is there in terms of 2 to the power data, like 2 to the power 1 is 2, 2 to the power 2 is 4, then 2 to the power 3 is 8, then 2 to the power 4, that is 16, then 2 to the power 5, that is 32, 2 to the power 6, that is 64, 2 to the power 7, that is 128, 2 to the power 8, that is 256, 2 to the power 9, that is 512, 2 to the power 10, that is 1024. If you remember this much numbers, it will be very easy for you to solve questions when it comes to COA as well as when it comes to digital electronics, right? Now, my dear students, I am going to explain you how we can represent numbers in 2's complement form, right? So sometimes you may be given with any number and you need to identify what is the signed data representation inside computer. So remember, always we represent data in form of 2's complement, right? So here, let me give you some examples. So when it comes to some representation, then you should know, like as if you are given with numbers over here, you see, I'm just giving you some random numbers. Now, you want to represent this, right? So how to represent that in number which is there in terms of decimal number, right? So first of all, you will have to take 2's complement of this, right? So if you take 2's complement, then let me explain you one shortcut method. So that will be definitely increase your calculation speed. So as if you represent this in 2's complement, then first of all, you'll have to see first digit over here, right? And that is what? 1 over here. So you'll have to see from this direction, right? You'll have to see from this direction and you'll have to identify first one. So here first digit 1, that is available over here. So after that first digit, whatever digits are there, that you'll have to complement. Like 1, after this 1, that will be 0, then double zeros are there, so that will be double 1, then double ones are there, that will be double 0, right? So this is how 2's complement that we can have. So whenever you see that digit from right side, right? So from right side, you'll have to identify first one. So up to first one, whatever numbers are there, that you need to keep it as it is. Then after, whatever digits are there, that you'll have to complement, right? So this is what 2's complement. Now what is the magnitude of this? So if you observe how to identify magnitude, so first of all, when you want to calculate magnitude of binary number, you just need to note down data like this. You see 1, then 2, then 4, 8, then you will be having 16, then you will be having 32, right? So here, how to identify the values? So 1 plus 4, 5 plus 8, so that will be 13. So 13 is the magnitude, and as per this first digit, that is 1, based on 2's complement, this is minus 13. And remember, minus 13's 2 complement, that is plus 13, and plus 13's 2's complement, that is minus 13, right? So whenever you have been given with data in which first digit, that is 1, at that time, remember, that is a negative digit, right? But negative digit doesn't mean like directly you can have value. You will have to do 2's complement, then only you will be having value, right? Let me explain you a few more case studies over here. Like, let me give you one more example over here, so that will improve your understanding further. So here we are given with 1 1 1 1, then 0 0 1 0 0, right? So this is what the digits that is given to us. Now question is, what is the value, right, inside a computer when it is representing this binary digits? So remember, it is always there in 2's complement, and first digit, that is 1, means this is negative data. So you'll have to take 2's complement of this. So let us take 2's complement of this, and here I'll be explaining you this by shortcut method, right? So what you need to do, you'll have to see it from this direction, right? And you see, up to what we need to see? Up to first one, we need to copy the data as it is. So you see 0 0 1, that is how it is there. So 0 0 1, that I need to keep as it is. Then whatever numbers are there, that I need to complement. So double zeros are there, so now that will be double 1. And you see 4 times 1s are there, so that will be 4 times 0, right? Now to identify the magnitude, what is the basic trick? First you will have to write 1, then 2, then 4, then 8, then 16, and then zeros are there, so I don't need to write further. So what is the value of these numbers? You see 4 plus 8 plus 16, so that is 28, right? So here, my dear students, magnitude is 28, but that is coming after a 2's complement, means here as per this first one, this is minus 28, right? So my dear students, here many of the times you will be given with data, and at that time directly you will have to identify 2's complement first, that is the magnitude, and as you have done 2's complement, you will have to change the sign over here. As if data is positive, then initial digit, that will be 0. So first digit, that will be 0, MSB will be 0. For that directly you will have to identify the magnitude, right? But for negative data only, you will have to do 2's complement. Here one more interesting thing that you need to observe here. If you observe, see, even if you have data over here which is up to this, right? Up to this means this much data is there, 1 0 0 1 0 0. Then also you will be having same magnitude. You see this 3 0, that doesn't make any sense, right? But you see here in negative, extension is happening as per ones, right? So here what I mean to say is, if initial digits, remember, if initial digits are sequence of ones, right, then it is just an extension of sign, right? Extension of sign means here you see how many bits that we have used, 1 2 3 4 5 6 7 8 9. So we have used 9 bits. We can represent this by having 6 digits only. You see 1 0 0 1 0 0, so that will gives you minus 28 only. But here by 9 bits also we can represent minus 28. It is like this. You see, for example, you want to represent 100, right, in normal system, then you can write 100, but you can write 100 as per 0 0 0 0 1 0 0. So if you pad zeros initially, then that will be 100 only, right? It is not like you are having larger digit. But thing is, you will have to understand this concept, like when it comes to negative data, at that time you will be padding ones. You see, for negative data in 2's complement, we are having ones that is been padded over here. So for example, there are 10 ones in sequence, then you will have to consider that in this way, like those 10 ones, that is just representing what? It is just representing extension of sign, right? So negative, that will be extended by ones, positive, that will be extended by zeros. That you need to keep in your mind when you solve problems. This concept is very essential when you solve problems. In future coming videos, there will be many problems that will definitely improve your understanding. If anything that you like to share it with me, please note it down in comment box. I'll be happy to help you. Thank you so much for watching this video.